Alright guys, we are writing, interpreting, and simplifying expressions. So we're still in lesson 2.1 and we're going to go through some examples here so that you can see how we can simplify these expressions. Alright, so it says simplify the expression and then justify each step. Drag an item into each box to show and justify the solution steps. Alright, so here we have an expression. So the first thing we're going to do is distribute. If you remember, distributive property tells us to multiply the number in front of the parentheses by both numbers inside the parentheses. So we're going to multiply each of these in order to get the answer or the next expression. All right, so we've got 2a, that stays the same for now, plus 3 times 2b is 6b. Plus 3. So remember 3 times 1 is 3. Make sure you multiply the 3 by everything inside the parentheses. That's distributive property. So if we come down here, we're going to see 2 that start with 2a plus 6b plus 3. So which one of these will be the rest of it? So we're going to have negative 6 times a, negative 6a, and negative 6 times negative 7. Well, that is positive 42. And then minus 10. So we can see that this is the expression that we want. Now what did we do? We did distributive property. So we just need to name that. And then here we're going to combine like terms. So we're going to take our a's, add those together, take the b's. There's only one b, so it stays. And then 3 plus 42 plus negative 10. So if we combine like terms, 2a minus 6a is negative 4a. So we have 2 with negative 4a. And then we have 42 minus 10. 42 minus 10 is 32. 32 plus 3 is 35. So let's move this up here. And then what did we do? We simply combine like terms. So we can go down here and check this and see how we did. And there we go. All right, let's see if there's any more questions here. All right, the expression is the simplified version of this expression. All right, so if you go back to number 1, that's the expression we got. This is the expression we started with. Now we're going to just look at how those relate. What is one way to show that the two expressions are equivalent? Change all the consonants in both expressions to the same numerical value. Remember, the consonant is 35, so I can't change that number or it's going to change my expression. So number 1, or the first one, is not correct. Change all the coefficients. If we change the coefficients, again, we're changing the numbers in front of the variables. We can't do that or it's going to change the whole problem. And then it says choose additive inverses. Well, we know that we do additive inverses when we're solving equations, but not when we're combining like terms or working with expressions. So it's not going to be that. And then it says choose numerical values for a and b. Substitute the values into each expression and see whether the resulting values are the same. So you know that a and b are our variables, and those are our unknowns. So what it's saying is choose a value for a, plug it in here. Plug the same number in for A on this one. Choose a number for B. Plug it in here. Choose the same number and plug it in for here. And then once you evaluate those with those numbers you pick for A and B, then see if those two are equivalent or the same. So that would be the best answer for this one. So you can always choose values to plug in for your variables and just see if it makes sense. See if those expressions are equivalent. All right, let's look at another one. This one says show that the expression or that the two expressions are equivalent by substituting values and evaluating. This says let A be 2 and B be 3. So they're just choosing random numbers to plug in for the variables, and you're just going to plug it into both expressions and see if they work. So if I do that, on the left side, the first thing I'm going to do is say take 2 and plug it in for A. So that's going to give me 2 times 2 plus 3 times 2, and B is 3, so that's the B, plus 1 minus 6, and then 2, my A is a 2, minus 7, minus 10. So we can see all we did on this first step was plug in 2 and 3 for my variables. All right, so I'm going to do the same thing on this side, negative 4 times 2. So down here, negative 4 times 2 plus 6 times 3 plus 35. So simply substituting the values in. So the question mark here, we're checking to see if these two things are equivalent. All right, now that we have numbers plugged in for our variables, now we can simplify. So if we simplify here, we're going to have 4 plus, if we have 6 plus 1 is 7, 7 times 3 is 21, and then here we got negative 5, negative 6 times negative 5 is 30, and then bring down the negative 10. All right, may take you a minute to work these out. If it does, go right ahead and pause the video at any time and work these out on your own. It'd be better for you to understand the process by doing it yourself if you can. But I'm just here to show you some examples and don't want to make the videos too long. But again, at any time, if you need to pause the video, please do so. All right, for this one, you've got negative 4 times 2, which is negative 8. And 6 times 3 is 18, and bring down to 35. So we simplified this into this expression now. All right, we're going to go back over here. And we're going to say, let's add those up. So I've got 4 plus 21 plus 30 minus 10. And that's going to be 45. All right, so we've got negative 8 plus 18. That's 10. 10 plus 35 is also 45. So you can see that these two did simplify into being equivalent expressions. And again, if you're doing it on here, you can check your answers. All right, let's do another one. Simplify the expression, justify each step. Okay, again, we've got parentheses. That means we have to distribute. So we're going to do 5 times x and 5 times 3. We're also going to do negative 6 times 2x and negative 6 times negative 4. So if we come down here below, we're going to have 8x times 5x plus 15, and over here negative 12x plus 24. Again, if you need to pause this, go ahead and do so. All right, so that is distributive property. All right, and then after that, we are going to combine like terms. So we're going to combine all of our x's, and then we're going to combine just our numbers. So we're going to have 8x plus 5x, and then minus 12x. So 8 plus 5 is 13. 13 minus 12 is just x. And then 15 plus 24 is 39. So we're going to have x plus 39. And that is simply combining like terms. So again, we can check that. Make sure that we are correct. And then move on. All right, this one is lengthy. It says set the expression and the other expression equal to each other. Then solve the equation formed. Show each step. All right, so it says on step 1, this is setting it up. So we have to go down there and find the original equation on the left side. And this one's kind of hard because you have to scroll up and down. So you can see the 8x plus 5 times x plus 3 minus 6, 2x minus 4. So we got the original step. So now we don't need anything from above. All right, so what is the next step? All right, so the next step is going to be distributive property. And we've done that a couple times already. So we got 8x plus 15. And then minus 12x plus 24. All right, on this side, there's nothing really to simplify. So we're just going to bring that along. And it even says apply a property on the left. So since we can't do anything, we're going to bring the same thing down. And now we're going to combine like terms here. So if we combine like terms, we're going to get x plus 39. And again, we're going to bring down the x plus 39 here. Now, this, if we subtract x from both sides and we subtract 39 from both sides, we're going to get 0 equals 0. So we can see that if we simplify those two sides, they come out to be the exact same thing at the bottom. All right. Last one, let's see what it says here. All right, use the information to answer A and B. An original expression and its simplified version are set equal to each other to form the equation, and the equation is solved as shown below. All right, so this is what we did in the last process, and we got 0 equals 0. So if you get 0 equals 0, how many solutions does that mean? Well, since those are equal, and that's a true statement, that means any number you plug in will be a solution. So that means that you are going to have infinite solutions. So that means any x that you choose, any number you plug in for x, if I say let x be 2, I'll plug 2 in here, and I'll plug 2 in here. I check to see if they're equal. Yes, that will work. If I plug in 4, and I'll plug in 4 here, then I should get something equals something at the bottom. So this is going to be infinitely many solutions. That means there's no limit to how many solutions there is. Any number x you plug in should work. Or any number you choose for the variable x, when you plug it in, it should give you a true statement. All right, so what does the solution of this equation say about the original and the simplified expressions? Since there are only two solutions, since there is only one solution, the expressions are equivalent for all values of x, so they are equivalent expressions. That's the one we want. All right, I hope this helps you simplify expressions and justify their steps a little bit. Again, if you have any questions, please let me know. I am always happy to help.